This video is going to cover some examples, 3 examples from section 10.3. The directions for this one are to simplify. So when we're looking to simplify a radical expression, we're looking for perfect roots as factors within that expression. So we're looking at 300. We're asking ourselves, is there a perfect square root, because the index here is 2. Remember, if it's not written, it's an understood 2. Is there a perfect square as a factor of 300? And in fact, there is. 100 is a perfect square. So we can rewrite the square root of 300 as the square root of the product 100 times 3. And now that product rule is going to come in handy because it's going to tell us that we can rewrite this expression like this. We can take each of the factors from that product, separate them out into their own radical expressions. The square root of 100 is 10. The square root of 3 we can't do anything with, so we write the answer as 10 square roots of 3. We don't write a multiplication sign in there because it's understood. And there are different ways to say this. This could be read as 10 root 3, 10 square roots of 3. So you'll hear it in different ways. Move on to the again, we're asked to simplify, and again it's a radical expression. It's a square root. So again, we're looking for perfect squares. So we can rewrite this. We'll look at the number first, and we see that the number is 4 times 2. And then, since it's a square root, any even exponent is going to give us a perfect square. This is m squared squared. So when you have a square root, you're looking for even numbered exponents. And then n we can't do anything with. So now we can take the 4 is going to come out. So the 4 is going to come out as its square root, because actually what we're doing, let me write out every step for this one again, is we have the square root of 4 times the square root of 2 times the square root of m squared squared times the square root of n. The square root of 4, perfect square, is going to give us 2. The square root of m squared squared is going to give us m squared. And neither 2 nor n are perfect squares, so neither of them can come out from beneath the radical sign. So they will stay in. And our answer will be 2m squared times the square root of 2n. The third example I want to do is a little more complicated because it's a third root, and sometimes it's hard to think of perfect cubes. So again, what we want to do is look for perfect cubes as factors within this expression under our radical sign. Perfect cubes because our index is 3. So we can rewrite this. 54 is 27 times 2. And 27 happens to be a perfect cube. It's 3 cubed. Now, looking at s to the fourth, any multiple of 3 as an exponent will be a perfect cube, just like any even number will be a perfect square because it's a multiple of 2. And so we can take this and use the product rule in reverse to rewrite this as s cubed times s. That gives us a factor here that's a perfect cube. And I'm going to rewrite this. You will get used to doing these and you will not have to write as many steps after you get used to it. But I'm going to write it now separated, where we can use the commutative property of multiplication to put all the perfect cubes together and all the non-perfect cubes together. And now I can write this as the cube root of 27s cubed times the cube root of 2s. And now this radical contains all the perfect cubes. So we can go ahead and take the cube root of each of those. The cube root of 27 is 3. The cube root of s cubed is s. And then we have 2s still under the radical. And I see here that I forgot to write my index. I'll write it here. Good reminder, always look back and make sure you write your indexes. So we have, for a final answer, 3s times the cube root of 2s.